Okay, so chapter 7 is the last chapter we're going to do. It's over conics, so we'll be doing a lot of graphing in this chapter. What we're going to start with in 7.1, 7.1 isn't really set up like the other sections you're used to doing or the rest of this chapter. Like the homework, like the book problems, they're kind of like in a paragraph form. They're not word problems, but they just kind of a lot going on. So once we get through 7.1, the 7.2, 7.3, 7.4, those are all pretty straightforward, kind of more like we're used to. So 7.1, we have to do some background stuff and kind of learn a brief overview of the rest of the chapter. So what we'll do today is A, objective A. And so some formulas that we're going to have to remember are the midpoint and distance formula. So our midpoint formula and the distance formula. All right, so when you do midpoint, you're trying to find a point, right? You're trying to find the halfway point between two endpoints. So it's still going to be an ordered pair, and it's just the average of your x's, so x1 plus x2, and then divide by 2, and the average of the y coordinates. Okay, so you still end up with a point. When you're trying to find distance, you're trying to find a length, a measurement. So you're going to end up with just one number, and it will be positive because you're squaring here inside. So it'll be a positive number because it is a measurement. Distance formula comes from Pythagorean theorem. That's basically what it is. It's just kind of all in one set. Okay. So we want to take these 3 points. They form a right triangle. Let's find the midpoint of the hypotenuse, and then verify that this midpoint is equal distance from all 3 vertices. So that's a property of right triangles, that the midpoint of the hypotenuse is equidistant from all 3 vertices. So if I take these points and I sketch them on this graph, so I'm just going to mark my scale right here. Kind of by lines here. All right, so point 1 is right here. 32. Point 2 is right here. And point 3 is right here. Okay, so the hypotenuse Remember, hypotenuse is always across from the right angle. So my hypotenuse is P2 to P3. So I want to find the midpoint of that segment. Okay, so midpoint of P2, P3. I'll call that M. So add the x-coordinates, so 3 plus 8 divided by 2, and then 14 plus 2 divided by 2. So 11 over 2, and 14 plus 2 is 16 divided by 2 is 8. So my midpoint is 11 halves 8, or 11 halves is 5.5. Okay, so I'll mark that. So 1, 2, 3, 4, 5 and a half, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's it. So I need to then verify that M is equidistant from all 3 vertices. So their distances are the same. So M to P1 is the same as M to P3, which is the same as M to P2. Well, I know that M to P2 and M to P3 have to be the same because M is the midpoint. That's the definition of a midpoint, is that it's halfway between. So I really just want to find one of those distances and compare it to this one, M to P1, and make sure those are the same. So let's just do M to P3. So let's start there. So I wrote M first, so I'll call that x1, y1. P3, I'll call my x2, y2. All right, so if you go back to your distance formula, x2 minus x1, so 8 minus 11 halves, so minus 5.5 squared. It's just easier to type that in your calculator as a decimal. Plus y2 minus y1, so 2 minus 8 squared. Okay, leave it in radical form first, because if it is irrational, you'll keep it in radical form. So you should calculate that without the square root. That should give us 42.25. If you take the square root, you get a rational number. It's a decimal, but it ends. You get 6.5. Okay? Then I also know that 6.5 is the distance of M to P2, because M is the midpoint of that segment, right? So that's the definition of a midpoint. Alright, so then the other one I have to check is M to P1. again, I'll call M my x1, y1. I'll call P1 my x2, y2 this time. So 3, 2. So go ahead and fill this out. Write out distance formula. Calculate it. Remember, you're trying to get them to be the same, so make sure that you get 6.5 again.
So why did we solve this?
Well, you can. I just was saving a little bit of time because I knew that this had to be 6.5 because M is the midpoint of P2 to P3. So MP3 has to equal MP2 because it's the midpoint.
Right, and so this next one should equal the same thing.
It should, but I have to actually find it because it's not a midpoint. It's not part of that segment. But yes, it should, because that's the property that I'm trying to prove is that the midpoint of the hypotenuse is equidistant from all three vertices. Okay, so when we write this out, 3 minus 5.5 squared plus 2 minus 8 squared, again, should give us 6.5. Okay, so I verified. That the midpoint is equidistant. That was some practice using midpoint and distance formula. So what we're going to do now is we are going to draw a circle around this triangle. Okay. And so if we look here, if all three vertices of a triangle lie on the circumference, and that circle that is drawn around, we say that it circumscribes the triangle. So we're going to take that same triangle, and we're going to figure out the equation of the circle that is drawn around it. So first, let's remember what our circle equation is. So a circle, the definition of a circle, is a set of all points that are in equal distance from a given point. So that equal distance is called the radius, and our given point is called the center. So R is the radius. Remember, in your equation, it's R squared, so you're squaring that radius. And the center is H and K. But when you write it in here, the minuses, the minus H and minus K, mean opposite. Okay, so if we go back to our triangle on exercise 8, I want to write the equation of a circle that would circumscribe that triangle. So let's go back and look at our picture. I want all three vertices to be on my circle. So that means that my center is going to be here at M. And then this distance from M to the vertices will be my radius. Yeah. Okay, so my center is what the midpoint was, so over here. My center was 5.58. And my radius was 6.5. So if I use that equation, the circle equation, now that I have my center and radius, so this is my H and K, and I have my r. So I have x minus 5.5 squared plus y minus 8 squared equals r squared. So you need to do 6.5 squared. 42.25. And there's my equation of the circle. So it is a property that the center will be the midpoint of the hypotenuse, and the radius will be the distance from that midpoint to any vertex. Okay. So let's find the equation of a circle that would circumscribe this triangle, and then we'll sketch it. I'm going to sketch the triangle first so I know which side is my hypotenuse. So hypotenuse is always going to be your longest side. You might have to check distances. You might have to do distance formula if it's too hard to tell. But most of the time we should be able to tell. Let's see. So P1, P2, P3. So try that again. All right. So it looks like my longest side would be P1, P2. So okay, I'm going to call that my hypotenuse. I need to find the midpoints so I can find the center of the circle. So the center is going to be the midpoint of P1, P2. So I'm going to do negative 6 plus 6 divided by 2, and 4 plus negative 1 divided by 2. So add the x's, divide by 2, add the y's, divide by 2. So 0 and 3/2, or 1.5. So graph was a little off, but the center is there. Okay, then the radius is the distance from the center to any of these three vertices. Well, the easiest one would be this one to check. Because if you just have a horizontal or vertical distance, you can just count units. You don't have to do distance formula. We'll still do distance formula just to practice, but I should be getting, okay, 1, this is at 1.5. So if I count down 1, 2, 3, 4, 5, 6 and a half. So I should be getting 6.5 for my radius. So my radius is going to be distance C to P3, or C to P1, or C to P2. I'm just checking P3 because that the vertical distance will be the easiest. So if I call C my x1, y1, and P3, x2, y2. So I'm going to do 0 minus 0 squared plus negative 5 minus 1.5 squared. You get the square root of 42.25 again, which is 6.6. So let's go ahead and write our equation, and then we will draw the circle around the triangle. Okay, so x minus, what's my x-coordinate of my center? 0 squared plus y minus 1.5 squared equals r squared, which is what? Yep, 42.25. Because it's x minus 0, you could just have written this as x squared. You didn't necessarily need to put the minus 0 there, but it's fine to do that. It's fine to have it there, but it's not needed. Okay, so let's sketch our circle. So I'm going to, I know that it has to go through all three vertices. So I know it goes through all three of those points.
So what school would you put x minus 0?
It will tell you how to put it in. Most likely this one would be multiple choice. But then I'm also going to use the fact that my radius is 6.5 to help me sketch the circle a little bit better. So I'm going to go to the right 6.5 from my center, 6.5 units, and then I'll also go up 6.5. So here's 6.5 will be about right here, and then 1, 2, 3, probably needs to be a little bit higher. So it should resemble a circle. Okay. So when it tells you to circumscribe, that means to draw. Okay, and then write the equation. Okay, any questions about this? Okay, that's where we're going to stop today. So tomorrow we're going to start on B, and we're going to be looking at some stuff with parabolas. Looking at parabolas a little bit different than we have before.